Hi everyone, today I will introduce the WalletManager to you. In the last video, I introduced how to configure the Brahma OS framework jar package in Android Studio and the example code for calling the Ethereum Wallet API. In this video, I will mainly introduce the example code for calling the Bitcoin Wallet API. I will demonstrate this new demo on the latest version of Brahma image. This is the interface to create a Bitcoin wallet, which can also be used to create the Ethereum wallet. The return value is a list of user-defined data for the wallet. In addition, the Create Ethereum Wallet and Create Bitcoin Wallet interfaces are also provided. These interfaces are time-consuming and need to be ran in the new thread. The Bitcoin wallet can only be imported by mnemonics at present. This is the interface to import the Bitcoin wallet. This indicates the wallet name, this indicates the wallet password, this indicates the mnemonics, this indicates the import mode, and here is the value corresponding to the mnemonic mode. Now let's import a Bitcoin wallet. Enter the mnemonics. Enter the password. Click the Import Wallet button. Wait for a while. We can see that the Bitcoin wallet has been imported and the block will be downloaded. Now let's check the interfaces for wallet update. This is the interface to update name, this is interface to update avatar, and this is the interface to update passwords. To update password of the Bitcoin wallet, users need to enter the wallet address as well as the corresponding old and new passwords. This interface can also be used to update the password of the Ethereum wallet. This is the interface to get the wallet list. We can see all wallet addresses here. The above two wallets were created when you start the OS for the first time. Under them are the newly created Bitcoin and Ethereum wallets. This is the interface to delete the wallet. If you want to delete a wallet, correct password need to be entered and verified. To create or import a Bitcoin wallet or to synchronize the wallet information after booting, you need to download the latest Bitcoin block information from the current block. The WalletManager server will send the corresponding broadcast and data during the process. In this demo, the broadcast was registered in the create function. This broadcast was sent by the callback function. This broadcast only broadcasts the file name of the wallet. The following broadcasts relate to the download of blocks. Besides the file name of the wallet, it will also broadcast some relevant data. This is the stream of the peer. This is the number of the left blocks, which is int type. This is the download progress, which is double type. This is the number of the left blocks that need to be downloaded. This is the latest state of the downloaded block. This is the left blocks that need to be downloaded. This means the download has been completed. For the newly created Bitcoin wallet, we can receive the download information from the broadcast receiver. And for the downloaded Bitcoin wallet, we provide the following interfaces. This interface is to check whether all block information has been downloaded, and the return value is Boolean type. This interface is to view the latest download block height, and the return value is int type. This interface is the time of the latest downloaded block. Let's check the download status of the Bitcoin wallets. This is the newly created Bitcoin wallet, which was still downloading. This is the default wallet. We can see that it has been downloaded and the information was synchronized to the latest block. Only the Bitcoin wallet has been downloaded. Can the accurate wallet information be obtained? This is the interface to get the balance of the Bitcoin wallet. It is a time-consuming operation that needs to be run in a new thread. The return value of this interface is the smallest unit of Bitcoin. Bitcoin wallet is a hierarchical deterministic wallet. The interface to get a count of private keys was provided. The return value is the int type. The interface to get a current receive address was also provided. The return value is a string of base 58 type. Let's take the default wallet as an example, for it has been downloaded. Therefore, its information is accurate. This is the balance, and this is the current count of private keys. Now let's take a look at the transfer interface. This indicates the Bitcoin wallet address. This indicates the recipient's Bitcoin wallet address. This indicates the password of the Bitcoin wallet. This indicates the transfer amount. The unit is BTC. This indicates the fee of per byte. The unit is the smallest unit of the Bitcoin. This indicates the node string of the transaction. During the transaction, WalletManager will send corresponding broadcasts. The broadcasts were also registered in the create function in this demo. You can see these two broadcasts. The first broadcast indicates the transaction request has been reported. The following broadcast will be sent when a block confirms the transaction. The hash string and the amount of confirmed blocks will be sent, which are in types. After 6 or above blocks confirm the transaction, no corresponding broadcasts will be sent for this transaction. Now I will show you how to make a transfer. I'm going to make a transfer from the default Bitcoin wallet address to the newly imported Bitcoin wallet address. I will transfer 0.01 BTC. Enter the password and click the Transfer Bitcoin button. You can see the return transaction hash. Copy the return transaction hash and paste it on the website. We can check the information of this transaction. Now let's take a look at this interface. This interface is to obtain the latest pending amount of a specified Bitcoin wallet. Okay, move to the next interface. Here we can check the confirmed blocks. Past the return transaction hash, we can see that there is one block confirmed this transaction. Now look at the interface for obtaining transaction details. The return value of this interface is a list of custom transaction details, which defines some basic information, among which data pairs of the input and output lists represent wallet addresses and the amounts respectively. Let's check the transaction details of the default wallet. Pass the address of the default wallet. This is the transaction amount, followed by a string representation of the transaction details. This is the details of the latest transaction. Let's go to the website to see the transaction details of this wallet. The main address corresponds to 6 transactions. This is another address of the wallet, which corresponds to 2 transactions. So we can see there are overall 8 transactions in this wallet. Okay, that's all about this tutorial. All of our APIs can be found on the official wiki of Brahmaos. The code was also submitted to GitHub. If you have any questions, please post on our GitHub. Thanks for watching.